Well, let's continue with a few examples using the multiplication principle. And I'm going to suggest that you may pause the video before I write down the answer. It really is beneficial for you to think about what the problem is asking, take your time, and do your best to solve this problem, each one of these. So feel free to stop the video at any time and see if you can come up with the answer before I do. All right, 3 couples attend a movie, and they're seated in a row of 6 seats, and that's all we care about are the 6 seats. How many different seating arrangements are possible with those 3 couples? Well, let's draw our picture. Each one of these represents a seat, or the number of ways you can seat a person in each seat. You could think of this as being seat 1, task 1, how many people could we put here? Task 2, how many different people could you put here? Task 3, how many people could you put there? And so on. Well, you have 3 couples. That's 6 people. Out of those 6 people, how many of them could we put here? What are our choices? Any one of them could go there. 6. How many could go here? It doesn't say anything about sitting together. The couples don't have to sit together. So there are 5 people left. 5. Then 4. Then 3. Then 2. And by the time you seat 5 of them, you have no choice. There's only one left. So you don't have a choice. That person would have to sit in the last seat. Okay. If it's small numbers like this, I think it's probably worth multiplying out. And let's see, is there a nice way of doing this? I think so. You don't have to worry about the 1. Multiplying by 1 doesn't change anything, but I like multiplying 5 times 2, because that's 10. And then 3 times 4 is 12, and then 6. So I know that 6 times 12 is 72. So the answer is 720, the number of different ways the 3 couples, or 6 people, could be arranged in this row of 6 seats. All right, this one's tougher, quite a bit tougher. How many different seating arrangements are possible if the couples are seated next to each other? Okay, so I'm just going to give names. I'm going to call it like husband and wife, maybe. Husband 1, wife 1. Husband 2, wife 2. Husband 3, wife 3. So those are our 6 people with different names. Let's see. I need to draw a picture. 1, 2, 3, 4, 5, 6. Okay, think about this. Who has to be sitting in this seat? Any restrictions at all? Or could any one of the 6? Sure, any one of the 6 could be right here. It could be W3 or H2, doesn't matter. But how many choices do you have for this one? 1. If, for example, if you put wife 3 here, there is no other choice, but you have to put husband 3 here because they have to be seated next to each other. Okay, so now you can think of it as we've seated one of the 3 couples. How many are left here? Well, 2 people are done. So we have 4 possibilities left. Let's say, for instance, the first 2 seated were husband and wife 3. Well, you got 4 people left. Any one of them could be seated here. And then the spouse of that person has to be here. So no choice on that. If this one happens to be husband 1, this has to be wife 1. Okay, and now 4 of them have been seated. There's only 2 people left, and this in this seat could be either of the 2, and then this has to be the spouse. So this is a much smaller number. 6 times 4 times 2, that's like 6 times 8, which is 48. much smaller than 720. When you force the couples to sit next to each other, there's only 48 possible ways to do it. All right, number 11. An art gallery has several paintings from each of 5 artists. We're just going to think of them as being artist 1 through artist 5, A1 through A5. A wall has space to hang 4 paintings in a row. Let me draw a picture. That's the 4 paintings in a row. How many different arrangements by artists are possible? So we don't have the names of any paintings. It's just this will be one of the artists' paintings. This will be another artist's painting. This one will be one, and this one will be one. We're only concerned about who the artist of each one of these 4 pictures. Okay, how many different arrangements by artists are possible if the paintings are by different artists? So how many different artists could we choose from for the first one? Well, there are 5 artists, so 5. And they have to be by different artists. You can't reuse him, so, or her. Oops, I almost did. 5 times 4 times 3 times 2. 5 times 4 times 3 times 2. Because after you've used 3 artists, for example, in these 3, there are only 2 left to choose from, since you can't repeat an artist. Okay, so this is 20 times 6, which is 120. All right, part 2 of this. How many different arrangements by artists are possible if more than one painting by an artist is okay, but they may not be hung next to each other? So if this, for example, if you put artist number 1 here, you can't put artist 1 here or here. Okay, so you can't have 2 in a row by the same artist. So let me go ahead and draw these 4 again. All right. So how many choices do we have for the very first one? There are 5 artists, and you can choose any one of the 5. Now, how many do you have to choose for this one? You're not allowed to repeat the same one we just used there. We can't put 2 next to each other by the same artist, so you have to choose from the other 4 for that one. Now what do we have? What's this one? How many choices do you have for this one? It could be the same one as this one. You're allowed to repeat them, they just can't be next to each other. So all we have to do is avoid the one that's chosen here. The one that's chosen here means there are 4 left. And likewise, whatever this one is, he can't be here or she can't be here. So you have 4 choices. Think about that one for a while. And you may want to write out all the possibilities. I mean, that would be way too many possibilities to write out, but if you could start writing a few of them, you might understand better why it's 5 times 4 times 4 times 4. Let me 5 times 4 to the 3rd. That's a nice way to write it.